All right, so this one says find the vertex of the function. So how can we do that, you guys? I'm going to ask you, what process do we need to do to find the vertex? Do I have any suggestions? What do you guys think? It wants to find the vertex. Huh? You mean like the x-intercepts? Okay. So somebody said, what about the x-intercepts? I like that idea. That's a good one. Is there another way that we could do it? I got one. We could graph it on our calculator. So let's do the first process. Let's find the x-intercept. So the x-intercepts occur when y equals 0. So that means x minus 4 has to equal 0, and x plus 2 has to equal 0. So I'm going to add 4 to this side. And whatever I do on one side, I do to the other. So this intercept is at x equals 4. Over here, I'm going to subtract 2 from both sides, and I get x equals negative 2. So this is at negative 2. So if I were to sketch a graph of this bad boy, where this is my x-axis and this is my y-axis, at negative 2, 1, 2, the graph is going to cross here, and then over here at 1, 2, 3, 4, the graph is going to cross there. But how do we find the vertex with that information? We can. How do you think we could do it? I'll give you a clue. Where is the line of symmetry between these 2 points? Where should it be? It should be in the middle, right? You think it's positive too? Well, let's count. So the way that I do that is I go, okay, so if I go over one here, I'm going to go over one here. If I go over another one here, then I'm going to go over another one here. If I go over one here and I go over one here, where do they meet? Right? So that was a good guess. He kind of visually guessed it occurred when x equals 2, but it's actually x equals 1. Now, how does that help us with the vertex? When we know that the vertex, the x comma y, the x value is the line of symmetry or axis of symmetry. So somewhere on this graph, in other words, when x equals 1, that's the vertex. Because the vertex lies somewhere on this line, right? So I just need to figure out what the y value is when x equals 1. Can I do that? Yeah. How do I do that? Well, what I'm going to do is I'm going to go over here and I'm going to evaluate this and say f of 1. In other words, wherever there's an x in this equation, I'm going to plug in 1. So then this becomes 1 minus 4 times the quantity 1 plus 2. And I'm going to pause there and give you guys a chance to kind of write that down and process that. So now I got to do the math on that. So f of 1 is equal to, what's 1 minus 4? Negative 3, good. And then what's 1 plus 2? Positive 3. Okay, so then what is negative 3 times positive 3? It's a negative 9, right? When you multiply a negative times a positive, it's a negative. So that means at 1 comma negative 9, that, oops, got a little carried away with my old tablet here. Negative 9, that's the vertex. In other words, way down here is my vertex. One that's not drawn to scale, obviously. So my graph looks like this. How could I verify that and make sure that I did everything right? Graph it in the calculator. So turn your calculators on, grab your calculators, hit y equals, all right, so we're going to hit y equals, clear out what's in there, and I can literally put this in exactly how you see it right here. In other words, I could put x minus 4, oops, I got to put the 4, times the quantity x plus 2. And the calculator will do the rest. Hit graph. Oh, shoot, I don't like that one. So now this time I'm going to hit zoom, and I'm going to go down to the standard. Now z standard is from negative 10 to 10 for the x and y axis. I think that'll be fine because our vertex is at negative 9. Hey, that looks pretty close. Where does it cross? The exact same spot, right? So I'm going to take a picture of this, and I'm going to post it in here. Hey, looky there. Looks just like the one I drew, sort of. Mine's a little sloppier. But as you can see, we did get the points right. This is negative 2 comma 0. This is 1, 2, 3, 4 comma 0. My zeros always look like 6s. I don't know why. And then if I go over 1 and down 9, that's this spot right here, right? So that's 1 comma negative 9. And that is the vertex. Let's think about this vertex, though. The question doesn't ask this. Is that a minimum or a maximum? Well, no. What is the y value here? Negative 9. Will there ever be a y value lower than negative 9? In other words, will there be a negative 10 on the graph for y? No. So that's the minimum value. In other words, all the y values are greater than this value here. So that's why we call it the minimum value. And you're just going to have to memorize this. It's the bottom of the valley. So think about bottom. Bottom is minimum. So bottom of the valley. You can't get any lower than the bottom of a valley. And you can't get any higher than the top of a hill. So because this is the bottom of the valley, it's a minimum. Okay? And lastly, it doesn't ask for this, but we use this to find the answer. Our axis of symmetry was what? X equals 1. Because it was my vertex went through 1. Those two will always be the same. Okay?